Hi, I'm Kirk Olson, fisheries biologist with the Wisconsin DNR out of La Crosse. And today I'll be describing a project that we've been working on over the past few years, evaluating fish population trends and fisheries management activities in the West Fork Watershed. So before I get started, I'd like to acknowledge my co-authors, Kevin Mauel, fisheries technician with the Wisconsin DNR out of La Crosse, and Kristina Pechacek. She's an LTE fisheries technician who's been with us for several years here in La Crosse as well. And of course, I thought I'd also include a photo of myself since this is a virtual presentation, just so you know who's talking here. So the West Fork Watershed is located in southwest Wisconsin in the driftless area. It includes several very well-known trout streams, including, of course, the West Fork Kickapoo River itself. The stream is very well known in the state, maybe one of the most popular trout streams in the state. It's also been featured in several nationally distributed magazine articles and in Trout Unlimited's 100 Best Trout Streams in the U.S. What's remarkable about the West Fork Kickapoo Watershed is that the trout fishery there has emerged in the past 50 years. And this is thanks to largely conservation efforts within the watershed and throughout the region over the past 75 years that have allowed our fisheries management work to have any sort of an impact. And so, although I'm sure many of you have heard the conservation success story of the driftless region, I think it's worth at least briefly going through the story here. Anyway, beginning in the late 1800s, early 1900s, farmers that settled the region from Europe brought along with them a lot of agricultural practices that weren't well suited to the heavy summer rainfalls and steep landscape of the driftless area. They had practices which included things like, grazing the entire landscape, including the hillsides, which were primarily forested and had thin soil and were, areas of important areas for groundwater recharge. They also, utilized practices like using few crop rotations, plowing up and down the hill slopes. But in sum, all these practices that worked okay in Europe were very unsuccessful here, and ultimately they increased the amount of rainwater that would run over the surface of the land and decrease the amount of rainwater that would infiltrate the ground and reach the aquifer. And it doesn't sound like much, but this, changed the hydrology of this region in such a way that it caused major destruction, major erosion in the uplands and deposition in the valleys, which destroyed the trout streams, the hydrology of the streams, and also destroyed farms and towns, and had a very significant impact in this region. Conservationists at the time recognized that this was an opportunity to use some of the techniques that they had been developing for reducing erosion in agricultural areas. And so in 1933, the Soil Conservation Service, which is now the NRCS, established the nation's first watershed project in the Coon Creek Watershed, which is right next to the West Fork Kickapoo Watershed. And what they did right away was bring in, some of the well-known conservationists and researchers at the time, including folks like Aldo Leopold, and they ended up developing this project where they worked with farmers to, basically reduce erosion and increase groundwater infiltration on their farms. And so this was a different way of looking at things. Instead of trying to basically fix the symptoms of poor land use, they were trying to address it at its source. And so some of the practices they implemented were, things like, fencing the hillside, or implementing fencing the hillsides from grazing, or implementing contour strip planting and gully stabilization. All these different practices were implemented on the farms depending on their specific situation. And so these efforts were highly successful in not only reducing erosion and increasing groundwater infiltration, but also in improving farm productivity. And because of that, many of the practices that were used in the Coon Valley Conservation Project spread throughout the area into places like the West Fork Kickapoo Watershed. And this really set the stage for the recovery of trout populations in later years. Within the West Fork watershed in particular, recovery of the system's hydrology took some time. And so you can see from this graph showing minimum mean daily discharge as a proxy for base flow at a site downstream of the West Fork Kickapoo, that recovery of base flows didn't really wasn't really realized until the 1980s. And similarly, peak discharge as a kind of a proxy for large flood events, those didn't begin to attenuate until the 1980s as well. And this was around the same time that fisheries biologists began to recognize the potential for the West Fork Kickapoo River and its tributaries for supporting naturally reproducing trout populations. Anyway, so beginning in the later 1980s and through the 90s into the 2000s, there was a lot of effort by fisheries management to speed up the recovery of trout populations through habitat restoration, trout stocking of wild strains of both brook and brown trout. And this helped speed up the recovery and ultimately lead to the renowned fishery that exists in the West Fork Kickapoo watershed today. So although the West Fork watershed is home to some of the most popular trout streams in the state, there hasn't been a comprehensive evaluation of trout fisheries management activities or fish populations in the watershed. So the objectives of this project were to summarize current and historical data from the West Fork watershed, evaluate current fisheries management activities there, and then finally make recommendations for future fisheries management. With the presentation today, I'll be focusing on objective number 1. I tried to fit this whole comprehensive report into a 20-minute presentation, and that wasn't really feasible. So today I'll be focusing on methods and results from objective number 1. So in 2019, the La Crosse Inland Fisheries Management Crew decided to switch from the standard stratified random trout sampling design to a watershed-based approach. And so we were inspired by crews to the south of us that had switched to this design in recent years. We did so for a few reasons. One being that we cover a very large area that includes 4 counties. And so the previous stratified random design, where we would sample streams on different rotations, 3, 6, and 12-year rotations based on their priority, resulted in a lot of driving in most years. And this watershed-based approach allows us to really focus in on an area and gives us extra time, because we're not traveling as much to even sample streams that that are maybe unclassified trout water. The other reason that we decided to move to this approach is that we feel it's probably a more appropriate management unit for trout, given that it's well documented that trout don't necessarily follow stream boundaries and will use the entire watershed to complete their life cycle. So for example, moving from moving from summer habitats to spawning habitat to overwinter habitat, trout can traverse large portions of the watershed. So we felt that this sampling design gives us a better picture of the trout population within a watershed, and really how that trout population is doing. So in 2019, we decided to start with the West Fork Kickapoo watershed. This map here shows the location of the West Fork along with the rest of the watersheds in our 4 counties that we cover. So the rotation numbers on the right were just kind of arbitrary. We split up these watersheds based on basically the amount of sites that we know we can complete in the course of a field season. And so the blue lines on the map represent classified trout water, and the dots are sites that we've done in the past. So we primarily surveyed the West Fork Kickapoo in 2019, but also a few sites were completed the year before and the year after, in 2018 and 2020. We followed the standard single pass sampling designs that are used across the state, which I won't go into great detail about, but essentially we try to sample 35 times the average stream width and collect all species within that sampling site. So in total, 35 sites were sampled in the West Fork Kickapoo watershed between 2018 and 2020, with most sites being sampled in 2019, and using our standard electrofishing sampling protocol. Depending on the size of the stream, we used either backpack, electrofishing equipment, tow barge electrofishing equipment, or a mini boom shocker in the unweightable portions on the lower end of the West Fork Kickapoo River. All fish that were sampled were measured to the nearest tenth of an inch and weighed to the nearest gram, since we like to mix up our standard and metric just for fun. And we also inspected all brook trout that were captured for adipose fin clips, because in 2019, all brook trout that were stocked, which included 2,190 yearling brook trout, all of them were given adipose fin clips to evaluate their contribution to the brook trout populations in the streams we sampled. So of the 35 sites sampled on 18 different streams in the West Fork Watershed, naturally reproducing trout were found at every site. This map here shows the location of sites that we sampled along with the species that were present in terms of brook or brown trout and their density. So the larger the symbol, the larger the area of the particular species, which is denoted by green and orange, the greater the density of that species. And so the big large green circles represent sites where there are lots of brook trout. Large orange circles represent sites where there were a lot of brown trout. Brown trout were present in 33 of the 35 sites that we sampled. The only sites that brown trout were absent were reaches that were isolated from brown trout colonization by impassable fish barriers. On average, brown trout relative densities were high across the watershed. They ranged from 95 to over 2,300 fish per mile relative density. When we compared, the average densities that we saw to recent surveys across the state on classified trout waters, we saw that 78% exceeded the median for the statewide distribution of relative densities of brown trout, and 39% exceeded the top 25th percentile statewide. So relatively high densities of brown trout where they were present in this watershed. So we found naturally reproduced brook trout at 28 of the 35 sites that we sampled. Their densities range from 11 to more than 3,700 fish per mile, relative density, or catch per mile, I should say. Compared to other sites sampled across the state, 28% of the sites that we sampled exceeded the statewide median, and 17% exceeded the top 25th percentile. So these brook trout densities were generally lower, especially when compared to brown trout densities in the watershed. Our most robust brook trout populations were present in headwater sites, particularly those where brook trout occurred in allopatry. And this video here, you can see is one of our higher density brook trout sites, and this was one of those reaches where brook trout occurred in allopatry on Upper Seas Branch. An interesting pattern that we saw with our results was that sites that we sampled in the kind of southwestern portion of the watershed typically had higher trout densities and also a higher percent of cold water stenotherm species, which is shown by this map here. So the darker colors represent a higher percentage of, or the kind of more blue colors represent a higher percentage of cold water stenotherm species, with dark blue indicating about 100% cold water stenotherm species. So that includes trout and sculpin. And so this seems to reflect the differences in bedrock geology. So when you look at a bedrock map of the watershed, you can see that there's a greater proportion of this limestone bedrock in that part of the watershed. And then when you map the springs as well, you can see there's greater spring activity and greater groundwater connection in that portion of the watershed as well. It's also worth noting that those streams in the southwestern portion of the watershed were some of the first to be classified as supporting natural reproduction of trout in the 1970s. So that's all well and good, but I imagine you also want to know where the big fish are at. So we also looked at the kind of the potential for the stream to support larger fish, or maybe possibly trophy fish, based on the mean max length, so the average length of the top 5 individuals of the species. And then we plotted it out over the watershed and the 35 sites that we sampled. And so we saw with brook trout that where we saw the largest individuals were those sites where they occurred in allopatry and they were isolated. There were also a few sites, headwater sites, where we saw, the top 5 individuals being fairly large as well, but generally not in the lower river sites. Brown trout, on the other hand, we saw our largest fish typically in the lower sites, lower portions of the watershed, and in the main stem, West Fork Kickapoo. There were a few sites in the headwaters that had fairly large brown trout, and these, at least anecdotally, seem to be associated with these headwater reaches where there were more pools than you would have expected given the size of the stream. Of course, that deserves maybe a little bit more evaluation to really verify. So we also looked at long-term patterns in brook and brown trout relative densities in the watershed. So this graph here represents all the stations that were sampled in the watershed between 1965 and 2020, with brook trout on the top and brown trout on the bottom, and the dots representing the relative abundance at each of those sites. The blue line represents a smooth fit, with the gray bands are 95% confidence bands. And so this was just to get a look at the pattern over the course of the years, and you can see that there's appears to be increases in both brook and brown trout relative densities, although we know that there have been changes in sampling methods. The magnitude of change seems pretty unlikely that this increase would be due just to improvements in sampling efficiency. We also ran just a simple 2-sample t-test on data before 1990 and after 1990, and saw that on average there was about a 2-fold increase in brown trout after 1990, and in brook trout it was an order of magnitude increase, given that they were absent from many sites prior to that. Our data also indicates that trout populations are extending both up and downstream. For example, we sampled 8 streams that were previously unclassified in this effort, and all 8 of those streams had naturally reproducing populations of brook and or brown trout. A really striking example of some of the changes that we've seen was on upper Bishop's Branch Creek in a headwater. And so here the stream actually had run dry as recently as 2012, but in 2019 when we sampled it, we found naturally reproducing brook and brown trout and a very stable base flow, which is reflecting a continued increase in base flows that we've seen in the region, and also is similar to some of the increases in groundwater levels that we've seen at gauges in other watersheds in the area. Another example was on the lowermost site of the West Fork River main stem, downstream of Highway 56. This site hadn't been sampled since 1975, and at that time only 22 brown trout per mile were captured. At this time there was also extensive stocking, so some of these fish may have originated from stocking. And then when we resampled it in 2020, we captured 144 brown trout per mile, all of which originated from natural reproduction, as there isn't any brown trout stocking in the watershed currently. So I should note that although these increases are really striking, they aren't unique to this area, and they've been seen in several other parts of the driftless area over the past 75 years as land use has improved, along with increased precipitation due to climate change. So for example, there's been work done in southeastern Minnesota that's shown similar changes, improvements in base flow, and transitions in fish communities from more warm water communities to those dominated by cold water species, and in particular brook and brown trout. So as I mentioned in the methods earlier, we also evaluated the contribution of stocked brook trout to the trout populations that we surveyed. So in 2019, we marked 2,044 yearling brook trout. These are all wild strain. They were all given adipose fin clips, and then we looked for fin clips as we sampled all 35 sites in the watershed. We found stocked brook trout in 6 of these sites, 3 on the main stem where they were stocked, and then 3 in small tributaries that they apparently swam up into. Their densities were quite low, particularly in the main stem where we stocked them, with the range being between 0 and 23 fish per mile, at sites in the main stem, and the average being 9 fish per mile. So they made made a very small contribution to the catchable fish that we surveyed in the main stem, West Fork Kickapoo. With that, I'd like to thank you for listening and acknowledge the many individuals who contributed to this project. Thanks.